This video is for Section 9.2, tests about a population proportion. So the first definition we'll talk about is a test statistic. So a test statistic measures how far a sample statistic diverges from what we would expect if the null hypothesis were true in standardized units. And so the test statistic is equal to the statistic minus the parameter over the standard deviation of the statistic. So this is a formula that you're going to need to be familiar with. So the one sample z-test for a proportion is a process that is very important to the next part of the statistics that you're going to learn. So it's a four-step process. The first step is to state what hypotheses do you want to test and at what significance level. Remember, we talked about a significance level in the Section 9.1 video from earlier. Then we want to define any parameters that you use. The second step is to plan, so choose the appropriate inference method and check conditions. The third step is to do, so if the conditions are met, perform the calculations, which would be to compute the test statistic and to find the p-value. And the last step, the fourth step, is to conclude, so to now interpret the results of your test in the context of the problem. So this is what it's going to look like. So you're going to choose a simple random sample of size n from a large population that contains an unknown proportion p of successes. To test the hypothesis, the null hypothesis would be p equals p0. Compute the z statistic. And so this is the z statistic here. So you're going to find the p-value by calculating the probability of getting a z statistic this large or larger in the direction specified by the alternative hypothesis HA. And so when your population is bigger than your PO, when your population proportion is less than your PO, and when you have the alternative hypothesis when your proportion does not equal PO. Use this test only when the expected number of successes and failures are both at least 10 and the population is at least 10 times as large as the sample. Basically, this PO is the proportion at the null hypothesis.
Noah Downey, please come to the main office. Noah Downey, please come to the main office.
So then when you see n times PO, that means your size n times your proportion at the null hypothesis. And then here, the n times 1 minus the PO, so n times 1 minus the proportion at the null hypothesis. And so these need to be both at least 10, so these are the conditions that you would meet that we talked about in this step, step 2. So an example that we've sort of talked about already, we talked about this example back in Section 9.1, but now we're going to apply the new things that we've learned so far to that example. So the chip producer of Section 9.1 has just received a truckload of potatoes from its main supplier. Recall that if the producer determines that more than 8% of the potatoes in the shipment have blemishes, the truck will be sent away to get another load from their supplier. A supervisor selects a random sample of 500 potatoes from the truck. An inspection reveals that 47 of the potatoes have blemishes. Carry out a significance test at the alpha equals 0.10 significance level. What should the producer conclude? So we are going to begin this problem by doing our four-step process. So the first is to state. So we are going to state what we are doing. So what we are doing is we want to perform a test at the significance level of 0.10 of, to write this part because it's easier to write it, null hypothesis, P equals 0.08, alternative hypothesis, P is greater than 0.08. And we want to tell what P is. So this is when P is the actual proportion of potatoes in this shipment with blemishes. So next, the second step is to plan. So when we plan, remember we're going to check to see if the conditions are met. So we say if conditions are met, we should do a one sample
Corey Williams, please come to the main office. Corey Williams, please come to the main office.
we should do a one sample z-test for the population proportion P. So the two things we need to check are, is it random? And then is it normal? So to check and see if it's random, we just want to make sure that there was some sort of random assignment. And so in there, it tells us that the supervisor selects a random sample of 500 potatoes. And so it was random. That meets our random condition. The second one is to check and see if it's normal. So if we would check to see if it's normal, then we are going to first assume that our null hypothesis, which means that P is equal to 0.08, is true. That means that the expected number of blemished and unblemished potatoes are, and then this is when we're going to use those kind of strange formulas that we talked about on the last slide. So we have to do N times PO, and that would be 500 because that's our sample that we're taking, times PO, which is 0.08. And when you do that, you would get 40. We also have to check that N times 1 minus PO is greater than 10. So we had to check to see that this was greater than 10, definitely 40 is greater than 10, so now we're going to move on to the next part. And so that would look like 500 times 1 minus 0.08. And so that would look like 500 times 0.92, which is equal to 460. Because both of these values are at least 10, we should be safe to do normal calculations. So we should be safe to assume that this is normal. Alright, so now we're going to check to see if it's independent. Okay, so we are sampling without replacement. So because we are sampling without replacement, we need to check the 10% condition. It seems reasonable to assume that there are at least 10 times 500, which is equal to 5,000 potatoes in the shipment. To have 5,000 potatoes in a shipment, not that big of a deal. So that means that, well, we basically have independent, so we're good. All right, next we have to do our do step. So this is step 3. So the sample proportion of blemished potatoes is going to be p hat which is going to be equal to 47 out of 500. So the 47 came from in our problem where it says an inspection reveals that 47 of the potatoes have blemishes. So our p hat is going to be 47 out of the total sample, which is 500, and that gives us 0.094. So now we're going to use this p hat in our test statistic. So our test statistic is going to be z equals p hat minus po over the square root of po times 1 minus po all over n. So we said that p hat was 0.094. We know that po is 0.08. We're going to divide that by the square root of po, so 0.08 times 1 minus 0.08 all over n, which is going to be 500. Whenever you do that in the calculator, you would get that z was equal to 1.15. Alright, so next we have to figure out what the p-value is. So to calculate the p-value, remember that the p-value is basically the area under the standard normal curve for a one-sided test. And so whenever we are finding the area underneath the curve, you're going to do normal CDF. Remember that when you do that, you're looking at from a certain place, everything to the left. And so this z that you found up here is where you're looking at. So basically we would be saying this line right here is our z is equal to 1.15, and so we're finding this area here. That's how we do the normal CDF. So now we're going to say, we're going to do 1.15 and then 100. So we'll go to the calculator. All right, so we'll go to second bars. We'll go to 2 normal CDF. Our lower bound is going to be 1.15. Our upper bound, we'll let be 100. Our mean will stay 0, and our standard deviation will stay 1 because we're assuming that this is normal. And when we do that, we get 0.1251. So our p-value is 0.1251. All right, so that takes care of our do step. Our last step is to conclude. So basically, what does all of that mean? So we would say since our p-value 0.1251 is greater than the chosen significance level of 0.10, so alpha equals 0.10, we fail to reject the null hypothesis, and we say that there is not sufficient evidence to conclude that the shipment contains more than 8% blemished potatoes. The producer will use this truckload of potatoes to make potato chips. All right, check your understanding. According to the National Campaign to Prevent Teen and Unplanned Pregnancies, 20% of teens aged 13 to 19 say that they have electronically sent or posted sexually suggestive images of themselves. The counselor at a large high school worries that the actual figure might be higher at her school. To find out, she gives an anonymous survey to a random sample of 250 of the school's 2,800 students. All 250 respond, and 63 admit to sending or posting sexual images. Carry out a significance test at least the alpha equals 0.05 significance level. What conclusions should the counselor draw? Okay, so this is going to be another 4-step process. So the first thing that we have to do is we have to state what's happening. So we're going to say that we want to perform a test at the alpha equals 0.05 significance level of the null hypothesis when p equals 0.20 versus the alternative hypothesis where p is greater than 0.020. Nope. 0.20. So, now you need to tell what p is. So this is where P is the actual proportion of teens at the school who would say that they have electronically sent or posted sexually suggestive images of themselves. All right, next we plan. So we say if conditions are met, we should do a one sample Z test for the population P. First, we want to see if it's random. So we would say the sample was randomly selected. And we know that because it says that she gave an anonymous survey to a random sample of 250. So basically just checking off that it was definitely random. The next thing we're going to do is look at normal. So we would say the expected number of successes which would be N times PO would be equal to 250 times 0.20. So 250 times 0.20 would give us 50. That just tells us about the successes. So now we also need to talk about the failures. And failures. The failures would be N times 1 minus PO, which would be equal to 250 times 1 minus 0.20. 250 times 1 minus 0.20 would give you 200. Now, in order for this to be normal, we need both of these to be at least 10. And so we see that the successes is 50, that's definitely more than 10, and the failures is 200, which is definitely more than 10. So we would say that the expected number of successes, 50, and the failures, 200, are both at least 10. That means we've met normalcy. So now we're going to move on and look at independent. So we would say there were 250 in the sample and 2,800 in the school. So the sample is less than 10% of the population. This means all conditions have been met. All right, next we do the do step, so step 3. Step 3 is to find the Z. So the sample proportion is the p hat. So p hat would be equal to 63 out of 250. which gives us 0.252. The corresponding test statistic, we would have to find Z. Now there is an easier way to find Z than using the big long formula, and that's to do it on the calculator. So to do that, you would go to your calculator, you would press Stat, then go to Tests, and then go to option 5, 1 prop Z test. Your PO, in this case, would be 0.20. Your X would be your successes, which in this case would be 63. And your N would be the number in your sample, which is 250. For this one, our guidance counselor said that she thought that the figure was actually higher, so we would want to do greater than. And then we'll calculate. So when we do that, we see that our Z is equal to 2.055. So we would say 2.056. Actually, let's do 2.06. Since this is a one-sided test, the p-value is 0.0197. So I could get that from the calculator. And we're close to what the calculator was. This is what the 0.197 is what the book gave. So we could change that. No big deal. All right, so next we conclude. So we say since our p-value is less than 0.05, we reject the null hypothesis. Remember, we check out our p-value, we see if it's less than our significance level, our alpha, and so our p-value that we found, that our calculator found for us, was less than the 0.05, and so if it's less than your significance level, then you reject the null hypothesis. So we would say it appears that the counselor concerns are valid and that more than 20% of the teens in her school would say that they have electronically sent or posted sexually suggestive images of themselves. So glad I did not have to see your face as we did this problem. And this is basically what it looks like on the calculator. This is for 89s. We don't have to deal with that. So you're looking at 83, 84. So this is basically what yours would look like. If you wanted to draw it, then you would see that you were looking at greater than, so all this stuff over here. Of course, if you did less than, it'd be over here. So next, let's look at a two-sided test. So according to the Center for Disease Control and Prevention, CDC website, 50% of high school students have never smoked a cigarette. Taeyeon wonders whether this national result holds true in his large urban high school. For his AP Statistics class project, Taeyeon surveys a simple random sample of 150 students from his school. He gets responses from all 150 students, and 90 say that they never smoked a cigarette. What should Taeyeon conclude? Give appropriate evidence to support your answer. So we start with state. So we would say, we want to perform a significance test using the hypotheses where you have the null hypothesis, where p is equal to 0.50, so that's from the 50% here, and the alternative hypothesis, where Taeyeon basically just thinks that the p does not equal 0.50. And so, of course, you have to tell what p is equal to. So you would say where p equals the actual proportion of students in Taeyeon's school who would say that they have never smoked a cigarette. Because no significance level was stated, we will use alpha equals 0.05. So remember, if they do not give you a significance level, we always use the 0.05. Okay, so next we're going to do our plan. So for our plan, we basically have to check and make sure our conditions are met. So we would say if conditions are met, we'll do a one sample z-test for the population proportion p. So we're going to check to see if it's random. So it says that Taeyeon surveys a simple random sample of 150 students. So is it random? Yes. All right, so next we will check and see if it's normal. So for it to be normal, we have to have our successes, quote unquote, and our failures, quote unquote, both greater than 10. So we're going to assume that the null hypothesis is p equals 0.50. And we're going to assume that it's true. Then the expected numbers of smokers and non-smokers in the sample R. This is when we do the N times P O, or P0. So N times P0, which would be your sample size, 150, times your P0, which is the 0.50. And so when we do that, we get 75. That's bigger than 10. And then you have to do N times 1 minus P0, which would be those who are not smokers. And so that would be equal to, actually let me move down here and do this so I've got a little more room. So I'm doing N times 1 minus P0, which would be 150 times 1 minus 0.5. And so that would also be 75. And so then we would basically say let me get to a place that makes sense. Alright, so then when we say, since both of these values are at least 10, we should be safe doing normal calculations. So basically we should be safe to say we think it's normal from here on out. Now we're going to check independency. So we are sampling without replacement, which just means he's not going to ask the same person twice. So we have to check the 10% condition. So basically, does it seem reasonable that there are at least 10 times the number in our sample people in the school? So it seems reasonable to assume that there are at least 10 times 150, which is equal to 1,500 students in a large high school. So remember, it tells you that he's from a large urban school, so it's probably safe to assume that there's 1,500 students that go to that school. So next we're going to do. So let's do this the quick way, doing this on the calculator. So we're going to go to second vars. Oh, no, second stat. Come on. So go to stat, go to tests. You're going to go to one prop Z test, so 5. Your P0 is going to be equal to 0.50. That came from in our problem. The X is the number of people that said that they were smokers. So that would be 90. Our sample size is 150. And this time we are going to do the does not equal. And so that just means that he doesn't say if he thinks it's larger or smaller. Just kind of wants to see what happens. So go with that. And then calculate. So now that gives us everything that we need. So it gives us our Z, which is 2.45. It gives us our p-value, 0.0143, and it gives us our p-hat, 0.6. From all of that, what is really the most important part is our p-value. So it gave us a p-value which is equal to 0.0143, not 2. So now you're going to conclude. So now remember, you're going to compare that p-value to your alpha that you were using for your significance level. So you're going to say since our p-value 0.0143 is less than our significance level, which was 0.05, we have sufficient evidence to reject the null hypothesis and conclude that the proportion of students in Taeyon's school who say they have never smoked differs from the national result of 0.50. Alright, so next we are going to do another check your understanding. So according to the National Institute for Occupational Safety and Health, job stress poses a major threat to the health of workers. In a national survey of restaurant employees, 75% said that work stress had a negative impact on their personal lives. Managers of a large restaurant chain wonder whether this national result holds for their employees. A random sample of 100 employees finds that 68 answer yes when asked, does work stress have a negative impact on your personal life? Is this good reason to think that the proportion of all employees in this chain would say yes differs from the national proportion of 0.75? Support your answer with a significance test. So you're doing a significance test. You're going to start by doing your 4-step process. So you're going to state. So you're going to say, we want to perform a test at, and you're going to have to go with a significance level, but they don't tell you what it is, so you're always going to let it be alpha equals 0.05. Of your null hypothesis, which is when your proportion is equal to 0.75 versus the alternative hypothesis, when your p does not equal 0.75. So it doesn't tell you that think it's higher or lower, just that it does not equal. So then you need to tell about what is P. Where P is the actual proportion of restaurant employees to say that work stress has a negative impact on their personal lives. Next, we plan. So we've got to check and see if our conditions are met. So we say if conditions are met, we should do a one sample z-test for the population proportion P. So we're going to check and see first that it's random. So in our information they give us at the top, does it say the word random? So a random sample of 100 employees, that means yes, it's random. So next we check to see if we can say that it's normal. So to say that it's normal, that means that our successes and our failures are both at least 10. So we would say the expected number of successes and let's go ahead and just do successes. So if we do successes, that's going to be our sample size times P0. And so our sample size was 100, our P0, 0.75. So 100 times 0.75, 75. So now we're going to do failures. So to do the failures, you're going to do n times 1 minus P0. So that would be 100 times 1 minus 0.75, which is going to be 25. So the expected number of successes and failures are at least 10. So we move on to independent. So we would say there were 100 in the sample, and since this is a large restaurant chain, it is very likely that there are more than 1,000, so that would come from 10 times 100. Workers in the population. So the sample that we're looking at is less than 10% of the population. So this means that all conditions have been met. So remember, because we are not asking the same people this question, we are sampling without replacement, which means we need to check the 10% condition. And so that's what this 10 times 100, which gives us 1,000, and checking to see if we think that 1,000 workers makes sense for our problem. So because we've checked random, normal, and independent, all conditions have been met. Now we're going to move on to our do. So to do the do, we need to find our p-value. So we can do that easily on the calculator by going to stat, over to test, one prop z test, which is option 5. Our P0 is going to be 0.75. Our X is going to be 68 people that said that work negatively affected their lives. The N is going to be the number of people in the sample, which is 100. We're not saying that we think it's less than or greater than. We're saying it's just not equal to P0. And so then we are going to calculate. So when we do that, we would see that our z is negative 1.6, roughly 2. And we would see that our p-value is 0.102 or 52. We also see that our p-hat is 0.68. So the important part from that is the p. So p is equal to 0.1052. So then we need to conclude. So remember now that conclude means that we're just going to compare the p-value and the alpha significance level, the 0.05, and just see how they kind of how they look to each other. So we would say since our p-value is greater than 0.05, which is our significance level, we would fail to reject the null hypothesis. So we would say we do not have enough evidence to conclude that the proportion of restaurant employees at this large restaurant chain who say that work stress has a negative impact on their personal lives is different from the national proportion of 0.75.